You are welcome back. We are in number 6. We want to treat this question, and it goes thus: a brass rod 2 meters long at a certain temperature. Information has been given. The length of the brass rod, let's call it L1, that's what? 2 meters. At a certain temperature. We don't know the temperature. What is the length for a temperature rise of 100 Kelvin? If you are looking for the next length, that means we are taking a look at L2. And the question says temperature rise of 100 Kelvin. Once you are giving anything in that form, that tells you theta 2 and 1 has been given. So change in temperature is what is given to the what? 100 Kelvin. So, and then the expansivity of brass is given as 18 multiplied by 10 raised to the power of -6 per Kelvin. This is the information that we are given. So, we are looking for L2. What do? We use the expression linear expansivity is equal to L2 minus L1 all over L1 change in temperature. So, let's go. The linear expansivity is 18, 10 minus 6. Then you have L2 minus L1. L2 is not known. That's L2 minus what's L1? We have it as 2. Then what's L1 again? It's still what? 2. Change in temperature is given. It's here, and that's 100. So we have multiplied by 100. So what do? We multiply and cross multiply here. So let's make this over 1. 2 times 100, this is definitely what? 200. Cross multiply that with this, I have 18 by 10 raised to the power of 6 multiplied by 200 equal to L2 minus 2. This is what we are having. So multiply this with this. Okay, what do you have? 2 by 18, what do you have? I have 9. Then 2 by, that's 6. 8, 16, 36. Then we have by 10 raised to the power of -4, which is equal to L2 minus 2. So what do? I collect Latent, taking 2 to the other side. I will now have, what do I have? That's 36 by 10 to -4. Then I add 2 to it to get my what? L2. Okay, this is what we have. In doing this, definitely the final answer will be A, which is 2.0036 meters. The final answer is A. That's 1991 question 16. So very simple one from there. So let's move to the next question. Okay, this one says, a 2000 watt electric heater is used to heat a metal object of mass 5 kg. Initially at 10 degrees Celsius, that's the initial temperature. If the temperature rises of 30 degrees Celsius, that is from 10 to 30, so the difference becomes 20. It's obtained after 10 minutes, that's the time. The question is, what is the heat capacity of the material? Take note, not the specific heat capacity, but the what? The heat capacity. So let's quickly take on that and see what the final answer will be. We have options on the board already. But taking a look at the options, what comes to your mind? Let's delete part of the answers for now. The correct unit ought to be joules per degree Celsius. Okay, I think all of them are in the right unit. So that means we must calculate before we know the final answer. So let's take a look at it. And then we have the question flowing from electric heater, okay, is used to heat a metal object. That tells you heat must be transmitted. So there is heat gain and there is going to be what? Heat loss. So let's take a look at what we have. So the heat loss will definitely be from the heater, and power from heater is IV. And we know that the heat is IVT. So since power is IV, we can now say the energy that will be transmitted from the heater is going to be PT. P standing for power, T for the time. And then it's received by a metal object. So the heat that will be received by the metal object, so let me put it this way. This is the heater. This is the object. Object will take it in this form. MC, change in temperature. This is what will happen. This young man will give out the heat and it will be received by the what? The hot object. Don't forget, we are looking for the what? The heat capacity. And heat capacity at this point in time is MC. Why don't we just take this one off and represent it with another thing and take, for example, CP to represent the heat capacity. So we can now equate the two of them, and that's all. Heat loss equal to heat gain. So what's the power? Is given as what? 2000 watts. Multiplied by what's the time taking? 10 minutes. Standard unit for time is what? Seconds. So that means we are going to convert the minutes to seconds simply by multiplying it by what? 60. I'm done with the heat loss by the what? By the heater. Let's equate it to the heat gain. That will be CP representing the heat capacity into change in temperature. What's our change in temperature? 30 minus 10 is going to be 20. So what do? We just divide straight away by 20. So this one goes, 0 takes guy, 2 takes this one. So that will now have 100 by 10 by 60. In multiplying this, we're going to have 60,000. What do we have? Do we have such an answer there? Yes, in standard form, 60,000 is 6 times 10 raised to the power of 4 joules per Celsius. That's all. Option A is the correct answer. So, this is JAMB, and you know there's no time. All you do is to go straight to the question and substitute, and that's the end of it. Let's take the next question that we have here, and that's question 8. Another calculation question. You always have calculation flowing from this concept of heat. And it says, all the heat generated in a 5 ohm resistor. Interesting question. We have been talking about current, voltage, but we have not talked about the resistance that could come up. All you need to know is your Ohm's law, and then we substitute, and that's the end of the question. So let's look at it. It looks a bit long, but very simple. All the heat generated in a 5 ohm resistor, that tells you resistance is what? 5 ohm. And the current flowing I is equal to what? 2 amperes. The time taken is 20 seconds. It's used to evaporate 5 grams of liquid. That's the mass of the liquid, 5 grams. Don't forget, we can work in grams. But why we're going to leave it in grams is the options that we are having. It's looking like, look at joules per gram. That tells you your answer should be left in grams. So leave your mass in grams. Don't tamper with it. So let's go. Which of the following is correct value of the specific latent heat of the liquid? Specific latent heat is represented with L. Don't forget that latent heat is mL. And the L can be fusion or vaporization. So with what we have on the board now, heat will be lost because it's generated by a form that's electricity, okay, and the liquid gains the heat. So I told you that the assumption is that heat loss must be equal to what? Heat gain, as far as there is no heat loss to the surrounding. That's the assumption. So from here, we can say heat lost by this must be equal to what? Heat gain. We are giving latent heat. So what do we have? Normally IVT has to be equal to what? ML, no longer MC theta, because there's no temperature involved. We are dealing with latent heat. So, what do we have here? We have voltage, but no voltage in the question. But do you remember your Ohm's law? Ohm's law says V equal to what? IR. The current passing through a metallic conductor is directly proportional to the potential difference, provided that our temperature and other physical components are kept constant. So, this is the mathematical analysis. So wherever we have V, we drop IR. We have V here, so that it becomes I. Then we have IR to stand in for V, and we have T equal to ML. Combining these together, it becomes what? I squared RT equal to ML. With this, you are done. So what do? Substitute the value. I squared. Your current is 2. I drop it there, squared. What's your resistance? 5. I drop it there, that's 5. Then your time taken is 20 seconds. You drop the 20. What's the mass giving? 5 grams. So, with what we have here, we have the current 2, that's 2 amperes. The resistance is 5. The time taken, 20. Oh, but from the question we have it as 30 seconds. So sorry, that's an error. So we have this as 30 seconds and not 20. So what's the mass given? It's 5 grams. We have it as 5, and we are looking for the latent heat. So straight away, what do? You divide through by 5. 5 takes away 5. Then this 5 takes this away. 2 squared is definitely 4. 4 multiplied by 3 will give me what? 12. That means I have 120 as my answer. What's the unit for latent heat? Joules per what? Per kilograms. But the question, it's in grams. The mass is in grams, so it's now joules per gram. And then if you look at the board, here we have C as the correct answer. So, but if I were you, A and D definitely is not part of the answer because the units, they are wrong already. Look at it, joules, joules. So the answer is between B and C. Assuming I'm giving 3 options to be in joules and 1 in joules per gram, I will definitely not calculate this work. All I need to do is just to pick the one that carries the right unit, and that's all. That you can gain time from question 8 in order to meet up with other work. I think that will really save our time when we are having such problems. Let's go to number 9. Question 9. It says, which of the following is common to evaporation and boiling? Which of the following is common to evaporation and boiling? A says it takes place at any temperature. Could that be true? Let's look at all of them before we pick the answer. B are surface phenomena. All of them happen in the surface. Is that true? Boiling happens everywhere, all the part of the liquid. So that cannot be the answer. Do they take place at any temperature? The first option, it can be, because boiling needs to happen at a specific temperature. So A and B out of the equation. Let's go to number C. Option C says involve change of state. I think that makes lots of sense. Both of them involve change of state. So before getting to D, there is one correct answer we have gotten. D takes place at a definite pressure. That's definitely not true. The correct answer is C. Involve change of states. So let's move to question 10. The melting point of a substance is equivalent to its what? What does it mean for something to melt? At the point of melting, that is its changing phase. That is from where to where? From solid all the way to what? To liquid. Then the question is now saying, what is it equivalent to? That point where it happened from solids to liquid is the same point where it will happen from liquid to solid. So looking at the option, there, B is the correct answer. Solidification temperature. Already we know that melting is from what? Solids to liquid. And the question says it's also known as what? That is liquid to solid. That means B is the correct answer. That's 2014, very recent one. And you have it from question 23. Let's move to the next one, question 11. It says, ice cubes are added to a glass of warm water. The glass and water are cooled by what? Let's look at what is happening on the board. Don't forget we have mode of heat transfer. We have the conduction, we have the convection, and we have the radiation. From what we have on the board, which can explain this concept? When ice cubes are added to a glass of warm water, what type of heat transfer will you notice? There is a contact. That is what? That is conduction. There is flow through the liquid. That is convection. That tells you you have two concepts happening there. So the correct answer, if you look through, is going to be C. That's conduction and convection. Definitely it's not conduction only. It's not convection only. It's not convection and radiation. Radiation has no place in this. So D is out, A is out, B is out. The correct answer is C. That's question 10 from 2001. Let me move straight away to question 12. Question 12. It said teapots are often silver coated. If you notice it, teapots are often silver coated. Why? To prevent heat loss by what? These are applied questions. Is it convection and conduction? Is it radiation only? Is it conduction only? And is it convection only? The teapot is meant to keep the hotness inside there and it should not get outside. So definitely we don't want it to radiate out. The correct answer is B. Radiation is the answer to it. So we have taken care of question 12, and then we've seen that the prevention of heat here is basically radiation. So we are going to be taking question 13. Let's see what happens here. The question goes thus. The earth is always cold at night. Why? This is an applied question. As physics students, don't just wave at anything that happens. Make sure you interrogate it. Why is this always happening? These are the things that makes your question, especially when it comes to JAMB. And that's what we are having here. Why is it that the earth is always cold at night? Option A says, sun no longer shines at night. Everybody will jump at this, especially once you are not physics students. Because, oh, there is no sun definitely everywhere, will become very cold. That's not true. Something else is happening beyond the sun. 2, which is option B. Atmosphere reflects the sun's energy at night. I think that sounds, at least, being a physics student, that will sound better. But we'll come back to interrogate that if possible later. Let's go to option C. Atmosphere absorbs the sun's energy at night. Wow, that is interesting as well. Option D says what? Earth radiates heat to the atmosphere at night. Could this be the answer? Should I leave it for your purview? But the correct answer definitely is D. Earth radiates heat to the atmosphere at night. Definitely making the earth feels cooler. So always interrogate every scenario that happens. Applied question is what you will see. Less than 30% you will have as calculation. So let's move to the next one. Question 14. It says, the mechanism of heat transfer from one point to another through the vibration of the molecules of the medium is what? We have option conduction, radiation, diffusion, and convection. Because of the concept of vibration, that tells you the object must be in contact. That tells you if that must be, it must be a solid. And what type of heat transfer happens in solid is majorly what? Conduction. So A is the correct answer. So if you must choose the correct answer here, then you go for A. Any other one is out of it. That's the mechanism of heat transfer from one point to another through the vibration. Take note of that word, vibration. Alright. The last question I have here is 2010 and it's question 18. 2010 question 18 and it's going this way. It says heat is radiated by all hot objects in the form of what? We have X-ray here, we have solar energy, we have light energy here, and we have infrared. This class, I've not really taken time on the concept of rays, analysis of rays. So I'm sure we're going to do that next time. But the correct answer here is definitely infrared rays. You always have this question repeated in the same form. That is A as the correct answer. So we are going to stop here at this point in time. From what we have done so far, anything under heat should not be a problem. Optics, and I'm sure we've had videos on the concept of magnets, which is one of the widest. So that's why we base our discussion more on heat and optics. And I know with this, you are going to do so well in your exams. So thanks for viewing. You have really given your time, but I want you to do more by doing research, doing more, okay? More of it will give you better grades. And I know A is just the base. And you know what I mean by that. If you can climb up to 90 above, it's not bad. So you can do it. So all you need to do is to do more research on the facts. So as time goes on, you will have more information from me on how you can get the whole fact about physics. From mechanics to optics. Optics, we have the heat, and then on electricity. And then I'm sure you are going to do so well this season. So have a wonderful moment, and then have a good moment with your exam. Thank you so much.